A high-focus plasma beam bites into the tube of a steel pole. The arc can be as hot as 30,000 degrees as it causes a cut as clean as a whistle, bright, shiny metal, no trace of dross. Plasma cutting, modern high-tech associated with the name of Kjellberg Finsterwalde from day one. Finsterwalde, south of Berlin, near the Spreewald. Kjellberg Elektromaschinen GmbH was founded here in 1922 by Oskar Kjellberg to use a patent for covered welding electrodes. The company became a benchmark for automatic welding technology and quickly established a global reputation. In 1962, the first industrial plasma cutting machines came out of Finsterwalde. 3 years later, together with the Professor von Ardena Research Institute in Dresden, the breakthrough was achieved: fine focus plasma cutting. Today, the name of Kjellberg Finsterwalde stands worldwide for plasma cutting made in Germany. Unlike autogenous flame cutting, plasma cutting is first and foremost a melting process. The idea is that a plasma beam is heavily constricted by a water-cooled copper nozzle. The resulting hot plasma melts the base material in the kerf and slips it out. Work pieces 0.5 to 160 millimeters thick can be cut. From any steel alloy, copper, brass and bronze, through to aluminium. A process that has simply revolutionized the thermal separation of electrically conductive materials. The crucial impetus for this continues to come from Finsterwalde, from Kjellberg's research and construction departments. Many joint developments with scientists from universities and institutes have emerged over the years. Before a machine goes into series production, it is rigorously tested. The best cutting parameters are determined and the useful lives of the wearing parts are checked, among other things. Kjellberg manufactures on its own production sites, with experienced specialists on modern machines and with the highest level of precision. Most of the assembly is manual. That requires instinctive feel and a good eye. There are up to 300 processes to be performed before a high-performance torch can be delivered. Quality inspection at every point of production is all important and guarantees high-quality products. The firm's technical facilities. Here, products are examined, tried out and also presented. Anyone who buys from Kjellberg is given technical advice and can be trained if desired. Almost 20 different plasma cutting machines make up the current range of products for handicraft businesses as well as for highly automated industrial manufacture. Conventional plasma cutting without swirl gas is often used for manual cutting tasks, whilst gouging with the plasma beam, even on high-grade steel, is a particularly clean process. Swirl gas technology has its origins here, in water. With this technology, a swirl gas is also used. It follows as a gas envelope around the plasma arc, constricts it and protects it at the same time. Cut quality and cutting speeds are both greatly improved. Swirl gas units are especially suitable for automated plasma cutting, such as cutting out contours, for frequent piercing, or in cutting discontinuous materials such as grids. Materials up to 160 millimeters thick can be processed. High focus technology. It's the top in state-of-the-art plasma cutting technology. It comes closest to achieving the long-standing aim of obtaining cut surfaces requiring no further work. With this technology, the plasma beam is heavily constricted and energy density is greatly increased. Swirl gas protects the nozzle from double arcs and material spraying out. The result? vertical shiny metal cut edges without dross, with an insignificant surface roughness and narrow kerfs. This technology is really versatile when workpieces need to be marked, punched or lettered. Modern control systems allow both 2- and 3-dimensional components with the most varied contours to be worked. Here, you can also use 2 torches at the same time. With the help of CNC-controlled guidance technology, plasma cutting is increasingly gaining ground in the automobile industry, after conquering the shipbuilding and steel construction industries. Significant rationalization effects can be achieved in combination with other technologies, as with this torch cutting technology, 26 meters long and 3.5 meters wide. It consists of 1 frame each for autogenous cutting and for 2 high-focus 160i plasma cutting machines. Or this combination of stamping machine and plasma cutting machine, shown at an exhibition. Here is a machine linked to a welding machine via a robot. First, openings are cut into a container. Then the plasma torch is replaced by an MAG torch which welds the attached pipes cleanly from the outside. Plasma cutting, a modern, forward-looking and economical technology with almost universal application in handiwork and industry. Kjellberg Finsterwalde, innovative plasma cutting technology at the highest level.